The purpose of this video is to go through the answer key for the recent review on rational functions. So this is number 1. You have a rational function that has an x minus 5 on the denominator and a plus 2 outside of the fraction. So if you remember transformations from earlier in the year, this plus 2 is going to make your parent function move up 2, and this minus 5 on the denominator is going to take your parent function and move it to the left. The right by 4. So you can use that information from earlier, or you can use what we've recently learned about rational functions in order to find more information about this graph. So there's no hole in this particular case because we don't have any factoring going on where we can cancel things from the numerator and denominator. So we don't have to worry about that here. There is a horizontal asymptote. When we're in this transformational form, remember this number on the outside dictates our horizontal asymptote. So since our parent function has been moved up k units, in this case k equals 2, your horizontal asymptote is at y equals 2. The second thing after the horizontal asymptote we need to look at is the vertical asymptote. That is based off of whatever would make the denominator equal to 0. So in this particular case, it would be x equals 5. So we're going to have an imaginary vertical line at x equals 5 where our function does not touch. Okay. Then we've got X-Intercepts and Y-Intercepts. You can see the Y-intercept right now. To find that, you plug in 0 for x. So when we do that, the denominator becomes negative 5. So you get 1 over negative 5, which is negative 1/5, plus 2. If you rearrange that as 2 minus 1/5, that simplifies to be 1 4/5, or 1.8. Okay, so your y-intercept is at 0, 1.8. Then my x-intercept, I can find that by plugging in 0 for y. This process is a little bit more challenging, but not too bad. So you're going to first subtract 2 from both sides because it's outside the fraction. And then we want this x variable to go from the denominator up to the numerator. So what we have to do there is multiply it by both sides. It looks like I'm missing a times symbol over here. But this on the left-hand side is negative 2 times x minus 5. And then on the right-hand side, these will cancel out to just give you a 1. Okay? So then you have a couple options. You can distribute if you want, or you can divide both sides by negative 2 right away. I distributed just so we didn't have to work all the way through with fractions. So then you would subtract 10 and then divide by negative 2 to get 9 over 2, or 4.5 in decimal form. So your x-intercept is at the point 4.5, 0. Okay? So the next thing is to then input all that stuff into a graph. So you get your horizontal asymptote at y equals 2, your vertical asymptote at x equals 5. The two intercepts are here and here. That shows us that we're clearly below these two values of the asymptotes in this region. And we know we go very close to the asymptote without touching it in both directions. Now, 9 times out of 10, you're going to be in the diagonal with the problems that we do. But you can always take a value of x over here and plug it into your original equation just to make sure. So if I plugged in, say, 7, you'd get 7 minus 5. So 1 over 2, which would be 1/2, plus 2 is 2.5. So 2.5 would bring you up in this region right here. Okay, so that's the first problem. Next, we've got number 2 that is already in factored form. This is the first problem where we do see a hole. Remember, any term that will cancel out through simplification on the numerator and denominator as a common factor will be where your hole is located. Whatever makes that expression equal to 0 is the x value of the hole. And what I recommend is canceling that out and rewriting the equation so you can use this more simplified version of the equation x plus 2 over x minus 5 throughout the rest of the process. Now to find the rest of the hole, the y value, we're going to substitute x equals 3 into this simplified version of the equation. So 3 plus 2 on the numerator, 3 minus 5 on the denominator. And we get 5 over negative 2, or negative 2.5. So there's going to be a hole in your graph at 3, negative 2.5. So the rest of the curve will be fine. You're just going to have an open circle at that spot along the curve. Okay, now when we have these more complicated polynomials on the numerator and denominator, we have to be careful about our horizontal asymptotes. There were 3 rules, and what we had to do is compare your degree for the numerator and denominator. Now you can get the same result from the original equation or the simplified version, but you see in both cases that the numerator and denominator have the same degree. When that happens, you just simply take the coefficients of each of these. In this case, they're both 1s. And that is your horizontal asymptote. So 1 divided by 1 is 1, so your horizontal asymptote is at y equals 1. Okay? Then your vertical asymptote is, again, whatever makes the denominator 0. You're going to use the simplified version of the equation because the original, that other factor is where the hole is. So we don't want to talk about that. We know the hole is there, but we still have an x minus 5 on the denominator, so you're going to have a vertical asymptote at the value that makes that 0, which is obviously x equals 5. Then you've got an x-intercept at y equals 0. Like the other problems, use the simplified version of the equation and not the original, and the math is a lot easier. The first step is to multiply both sides by the denominator to clear that out. In this case, we've got a 0 on the left, so 0 times anything is just 0, so you end up with 0 is equal to x plus 2, and x ends up equaling 2. So your x-intercept, where you cross the x-axis, is at the point -2, 0. Okay? And you can see the y-intercept, we're plugging in 0 for x. You end up with x equals, y equals 0.4, or 2/5. Okay? So you can see the graph that goes along with that. Again, the asymptotes are in red or pink. You've got your x-intercept and your y-intercept, and your hole. I accidentally drew through it here, but that is where the hole is located. It should just be an open circle along the curve. Again, if you're in one region like we see here, the other part of the graph is opposite on the diagonal most of the time. If you wanted to be 100% sure of that, again, take one of these x values over here and plug them into the simplified version of the equation and see whether the y value is above or below this asymptote. In this particular case, it's above again. Okay, so not a big deal. Now a little bit of a disclaimer for number 3. I originally meant to type in -3x plus 9 on the numerator, and that was going to give me another problem with the hole, but I accidentally typed a 3, so we'll just go with it and see what the problem looks like. There's not much of a difference here. It's just a little bit less practice with holes than I wanted to. So in this particular case, when you factor, there's actually no common factor that goes away. So we don't have a hole again in this case, as I just mentioned. Okay, your horizontal asymptote, since our denominator has a higher exponent from the original form here, you can also kind of tell from the factored form because it's x times x in the denominator and just an x on the numerator. So when your denominator has a larger degree, by default, your horizontal asymptote is at y equals 0. So it'll cover right on top of the x-axis. Then your vertical asymptote is whatever makes the denominator equal to 0. Since nothing canceled out here, we actually have 2 vertical asymptotes, one at x equals -3 and one at x equals +3. Okay, I should mention too, when you factor this denominator is called the difference of squares. There's notes about this at the top of the page there if you've forgotten that from previous years. Then our x-intercept, you plug in y equals 0. Again, you're going to multiply both sides by the denominator. 0 times anything is just 0, so we end up with 0 is equal to -3 times x minus 1. A little bit more algebra, and we find out that x equals 1. So your x-intercept is at the point 1, 0. The y-intercept, you plug in 0 for x. Simplify all this, we end up with y equals 1/3. So your y-intercept is at the point 0, -1/3. Okay, now because we didn't have any holes here, you end up with a funky looking graph. I said I wasn't going to give you too many of these, but and I didn't intend to. But there is this weird case where this middle section does cross through the horizontal asymptote. Okay, so I won't give you one like this on a quiz, but most of the time we don't have that. It's just a weird case. So usually, you don't have your graph crossing through an asymptote. It never crosses through a vertical asymptote, but once in a while with this weird case, it crosses through the horizontal asymptote in the middle. Okay, but as long as you graph appropriately, you should be fine. And again, if you're not sure where it goes above or below the line in these regions, you just plug in a value for x, and you'll see the result there. So I won't give you one that looks this ugly on a quiz. It'll be more like the previous examples. Okay, one last one. This one does have another hole. So we have, once we factor, again, the numerator is a difference of squares. The denominator is just a regular trinomial. You end up with this expression x minus 5 that cancels out. So we have a hole at the x value of 5, and we have a simplified version of the equation. To figure out the rest of the hole, we plug in 5 into the simplified version of the equation and solve for y. We end up with a hole at the point 5, 5. Then we have a horizontal asymptote that is based off of either the original or the simplified, and like a similar problem before, the degrees are the same for both, so we just look at the coefficients of each of these, and that would be 1 over 1, which is y equals 1. Okay, so you're going to have a horizontal dashed line at y equals 1. The value that makes the simplified form of the equation equal to 0 would be x minus 3 equals 0, which is x equals 3. Okay. Our x-intercept is at when y equals 0. Again, you just simply first multiply both sides by the denominator and solve for x. You end up with x equals negative 5. Okay, and the y-intercept is the easiest form. You plug in x equals 0, simplify the fraction, and we end up with 5 over negative 3, or negative 1 2/3. Okay, so you can see here your asymptotes are clearly labeled with dashed lines. Our x-intercept and y-intercept are plotted. Then we do the best to connect the dots. We just have this curved shape where we approach the asymptotes from all directions. You have your hole up here, and then we do our best to kind of fill in the curve. It doesn't have to be a perfect drawn value. If you wanted to be a little more precise, we can make the window bigger and see a little bit more of the curve. But that's it for now. We'll do some more practice, and hopefully you'll feel more confident with this as we go forward. Thanks for watching.